Hi Bob, it's good to see you. Bernice from Firth. Wow, what a view.
Thanks for coming today, Bernice, and it's really good to see the project get to this stage and
Absolutely.
about to pour the concrete.
That is fantastic. Yes, that's next week. So, you know, Dan, your builder, he's ordered just some standard concrete from Firth for the floor, and even though it's going to be a low carbon, we call it ECOMIX, it's going to be low carbon. It's around 20 to 25 less carbon. But you know, we're going to have a look and see what we can do to really sort of just get below a little bit by adding perhaps some fly ash into that mix.
Nice.
And then we'll be able to say, actually this house maybe reached what we call an EC30, so it's embodied carbon 30% less Hauiska baseline.
I think I love how we're always learning something new. Each project's better than the last one. So this project here is pretty typical of most of the hill homes we do, where we're using reinforced concrete block, retaining walls, and an intermediate concrete slab. This one's got speed floor, which is a little bit different. Sometimes we use unispan or interspan. But I think the key thing is we're able to include the hydronic underfloor heating in the floor, which we've found has been one of the big breakthroughs with energy efficiency. And the key to that is because we've got the retaining walls, we can have the concrete slab on both the ground floor slab and the first floor.
And I guess that's important too, because once you've heated that concrete slab, it's just going to stay heated. And the concrete slab, have you got the sun coming in? Is it polished?
So that's a big part of it. So we're utilising the slab sort of as a battery.
Nice.
We have solar and batteries. So we're storing the solar power. But I look at the slab as our second battery.
Yes.
And as long as it's well detailed and fully insulated, that is storing via the hot water, which is powered by a heat pump, which is linked to the solar. It's storing the solar generated thermal energy that we get from the sun.
And it's free.
Yeah.
It's free energy, isn't it?
Yeah, and I mean we've done that in the past with much simpler, smaller homes, and it's led to us having energy positive homes,
yes.
where we can actually generate more energy than what we're utilising. But it all comes down to the detail too.
Yes.
Having no gaps in the insulation and making sure that's really thought about.
Yeah.
Hi James.
Hi Bob. Thanks for having us.
Yeah, it's good to come to site and see what's happening with this project at this stage.
It's been fascinating, and just standing here in the wine cellar.
Yeah. Well, I mean the wine cellar. The reason this came about, Andrew's got a really great collection of wine, and we wanted to have a thermally separate, have a thermal break between this wine cellar and the rest of the house, which is going to be super insulated and at a constant temperature, with water underfloor heating, hydronic underfloor heating. So you can see just down on the ground here we've got this big thermal break, and then also with the walls, we're not connecting these walls thermally to the rest of the house because we want to take advantage of the ambient temperature of the ground, which keeps the wine at the right temperature.
So how do you break that thermal bridge with the reinforcing?
Yeah, well, this project and other projects we've used fiberglass rods instead of steel.
Right.
And sometimes we've got a garage, which is an unconditioned space, and we want to thermally separate the garage. We'll have those fiberglass rods between the garage and the house.
So Bob, a super home, not everyone would associate the amount of concrete that's been used in this build as being coherent with a super home.
Yeah, so we're thinking about what's the best use of materials, and with most things there could be a dozen criteria. It could be probably top of the list is aesthetics, but then what's the carbon, but embodied carbon in the materials, but also what's the longevity and the durability and the permanence. And so they're all things that need to be weighed up. And then this being on a hill, we're retaining, so it makes sense to fit the house to the site, and instead of taking away lots of material, we try and limit the amount of excavation. But here it made sense to have concrete block walls, because then we can support the floor above, which is also concrete.
Yeah, and you've been able to pour that concrete floor.
Yeah, I guess traditionally in the past we've kind of designed and built using concrete block inside out, with insulation on the inside. But it's probably only in the last few years people have started thinking more about external insulation.
Yeah, well, the problem was with, you have like a lot of the old block garages that people want to renovate and make it a livable space. And what they do is they'll seal the inside with mold seal to waterproof, and then they'll batten it and then put insulation on the inside. But of course that's changing where the dew point is, and it's bringing all the insulation and the condensation to the inside here, whereas it should be on the outside. So what we've done here is obviously put quite thick insulation around the outside, plus the additional insulation on the inside, so then the dew point moves to the outside. So
if in doubt, insulate out. I think I've heard someone say.
Yeah, that's right. Yeah. Trademarked. Yeah. But yeah, so that's like, I think there's a few articles around that now. So, and a lot of questions being asked about where the dew point is in a wall, which is a good thing that people are talking about.
Yeah. Yeah, and the other key thing is just eliminating any thermal bridges, making sure that insulation is continuous.
Yes.